All right, in this example, we are going to do it a little bit differently. We're just going to find the slope at C to begin with. So we'll set up our difference quotient with our limit. Okay, and it's this. Now, let's put it into this function here. So we'll have C plus delta x squared minus plus 2 and minus C squared plus 2. Okay, that's f of c, and this is f of c plus delta x. And this will become c squared plus 2c delta x plus delta x squared plus 2 minus c squared minus 2. Or delta x, and that becomes, let's see, we get some cancellations here. We got rid of that, and that, and that. And that leaves us just 2c delta x plus delta x squared over a delta x, which we notice now we can factor out a delta x. By the way, if you let that's 2 in there. If you let the delta x head to 0 right now, you're just going to have 0 over 0. But if we factor it, you're going to get this. And then you're going to get that nice cancellation. See, that's what's causing the 0, 0 over 0 thing to happen. Now, we're just really working with this 2c plus delta x. And as delta x goes to 0, we see that our limit actually is just 2c. Okay, that's heading to 0. Okay, now, so this, in a way, this is a function of c now, and we can give it a name. In fact, it has a name. It's called the derivative function. And it's evaluated at c, f prime of c. So this is a new function. It's called the derivative. Okay, derivative function. And the way I've written it here, it's a function of c. Now, remember, c in our problem has 2 different values. So we're going to use our function here to find these 2 values. And in doing so, we'll be calculating the slope at 2 different points, at 0 and also at 1. So 2 separate questions. So let's calculate f prime of 0. Well, it'll be 2 times 0, which is 0. That tells us the slope of f is 0 at x equals 0. Okay, a little bit more. Okay, and now we want f prime of, the other one was 1, f prime of 1 equals 2 times 1, because our function is 2c. So that's a 2, and that is the slope of f of x and x equals 1. Okay, so we had a 2, we also had a 0. So we found 2 separate slopes. So the utility behind handling the problem this way is that we don't have to do this limit computation for every value that we want to find a derivative of, or a tangent, slope of a tangent for this curve. We just use the formula that we've created. F prime is 2c. Okay, f prime of c is 2c. And then you can put in whatever value of c that you want, as long as it exists. We're assuming that this exists. So